Welcome, everyone. We are here today to talk about chip number 14. This is going to be some new conditions that are added to Chialisp. And we have with us Arvid and Matt. Do you guys want to introduce yourselves? Arvid first.
Yeah, I work on the blockchain team and a lot around the Chia RS, which is the Rust implementation of our condition checking, but also on the Python side on the blockchain.
Thanks. Matt?
Yeah, my name's Matt Hoff. My name's Quexington on Keybase, so you probably see me around via that. I've been developing Chialisp for the last couple of years, and yeah, I've had a hand in like a lot of the contracts that we've deployed and stuff like that. So I know a lot about how you use the conditions and what you might want with the new ones.
Awesome, thanks. And I'm Dan Perry, and I'm a technical writer here at Chia, and I am more or less in charge of chips right now. So I'm going to share my screen. One moment here, and we'll take a look at this chip. So a few questions that I just wanted to go through just to introduce everybody to this chip. To start out, why don't we talk about what the current state of these conditions are that we have right now that are high up here in this motivation section, and what do they do and what are they missing? Do you want to talk about that, Arvid?
Yeah. So these four conditions basically let you have a time lock essentially on a puzzle or on a solution, so that either a wall clock time must have passed or a block height must have passed before it's valid to spend the coin or spend the solution. Yeah, so and the four flavors of these is height versus wall clock time, and the relative and absolute means relative to the birth height or birth time of the coin that's being spent. So you can have, if you want a time lock relative to when the coin was created, you can use a constant. So that's basically what the existing ones let you do.
And so with all four of these, then they basically open up the ability to spend a coin after a certain amount of time, right? Like right. Before this time or block height gets reached, then the coin's not spendable. But if these conditions exist,
exactly.
Okay, and so what this chip wants to add, I'll scroll down here, are these new conditions. Do you want to explain what these, or why they're needed, and then what they are?
Yeah, so let's start with the bottom four, because these are the inverse essentially of the existing ones. The existing ones say you can only spend this coin after a certain height or a certain time. What these do is you can only spend a coin before a certain height, and they are intended to be the exact negation. So if you have one of each, so assert before seconds relative and assert before seconds, and assert seconds relative, and you have the same value, you're not, it won't be spendable. So it's right, it's the negation essentially.
Okay, so opposite of what we have, that's these four.
Right. There's the quirk. I don't know if I should bring up the quirk.
Might as well.
There's a slight inconsistency in how the existing conditions are handled. For the ones restricting the timestamp, so the assert seconds, they use the current block's timestamp to compare against, whereas the assert height conditions, they use the previous transaction block's height, which has this effect that when you talk about relative, like the main noticeable effect of this is that when you talk about relative height or relative time, you're comparing in one case against the previous block and in the other case against the current block. So it's not intuitive that you have this slight difference. So we're also intending to make this consistent in the soft fork. We can do this because we make it more restrictive. So if we compare against the current block height instead of the previous block height, that's a soft fork. And that way we can still make the new conditions that we're introducing be the opposite of that, and still sort of be consistent.
Okay, so this, what I have actually in this chip is slightly off from what you're saying. I think this is a more recent development, so I'll have to update this chip.
Yeah, so the way it's, it can be thought of as you're comparing greater than instead of greater than and equal to, because the previous height is, technically it isn't -1, but it's it's not the same as the current block height. So it appears as if what's described here actually with the greater than or equal to.
Oh, it does. Okay.
Comparison.
Okay, but then is what we're going to do now is to actually change the meaning of the current conditions to make them more restrictive. Is that what you said?
For the height comparisons, yes.
For the ones that, yeah, for the two of them, right? For
exactly.
Okay, so that will be these two. So we'll actually modify these slightly. Is that going to have any kind of security concerns associated with it, with changing the current conditions?
Most likely not. I think it's very unlikely.
I think the worst case scenario would just be that some coin that's locked right now will just be able to be spent one block later, right?
Exactly.
Okay, so you're not gonna, there's no possibility of bricking coins by changing this meaning a little bit.
Right.
Okay, and so this will then unify, I guess, I'm not sure what the right word is, the exact definition of all of the current four conditions plus the new four conditions will all be mean the same thing, if you get what I'm saying, greater than or equal to or less than.
Right, exactly.
Okay, and what about these, or do you have more to say?
No, I was going to move on to the next conditions.
Okay, so let's talk about the other four.
Yeah, so we threw these in here because they are simple to add and nice to have. So the assert concurrent spend and assert concurrent puzzle are sort of like announcements, but the other coin and the other spend doesn't have to cooperate. They don't have to create the announcement. So you can just assert that a puzzle is being spent, or a coin is being spent with a specific puzzle, or that a specific coin ID is being spent in the same block, only in the same block, or in the same spend bundle, really, if you're submitting a transaction to the mempool.
Okay, and how about the other two?
Well, real quick, I just want to elaborate on the use case of this. So if you've been writing Chialisp at all, you probably have run across where you will have some sort of coin that sort of anyone can spend, and or has some predetermined behavior, and you want to make sure that people can attach fees to that coin's spend. And normally the way we do this in our current writing of Chialisp is you will have to, when you write the puzzle for that predetermined behavior of the coin, you're going to have it make some kind of just announcement of nothing, so that any fee coin that needs to be dependent on that spend can assert that announcement. And this is really dangerous to leave out that behavior into a predetermined puzzle. So you could have it so that you cannot safely attach fees to a spend. And so we wanted to add something that takes away the need to for the dependency to have to announce something. We just want, or I guess that's not the dependency. What's the coin that is being dependent upon? We wanted to take away the the necessity for it to create something, and just make it so the dependency can just create itself as a dependency on a coin without the other coin having to do anything at all.
Okay, thanks. How about the other format? Do you want to just continue, and what would these be used for? What's the main use case?
Oh, sure. So this one is a lot more kind of clear. Like they're the inverse of the other time locks, right? So previously, right now, all of our conditions are made in such a way that no spend that is currently valid will ever become invalid. So by adding these conditions, we kind of broke that paradigm a little bit, where you can now make a spend that is valid for a time and then becomes invalid and potentially forever. This is if you're like experimenting with Chialisp, sometimes you'll want to write things like this a lot. You want to cut off certain code paths at a certain time, like you want to give someone the opportunity to do something and then cut off that opportunity. But the big use case that I think is mentioned in the chip is offers. If you right now offers require positive action to cancel, you need to do something on chain to cancel the offer. But if you include this condition in your signed puzzle that you're giving to people to take, then at a certain point, even if they push your spend, it's going to output this condition and it will no longer be valid once it hits the chain. So it's really powerful stuff, and it makes sense that it should be in there. It's just we didn't have it in at the beginning because of some implementation complexities, I think.
Oh, okay. So there wasn't some kind of philosophical reason not to include it at first.
I think that if I wasn't involved in it, but I think it's borrowed from Bitcoin is the idea that no, I think there's a word for it too. I don't remember what it's called, but that no valid spend should become invalid because it messes with some block creation logic. Makes it a little bit more complicated, but it's not like inherently bad.
Okay, and when I first heard about this, that we might add these, I was kind of nervous because it sounds inherently bad because you might have bricked coins. But do you want to, Arvid? Do you want to explain how this is going to work and why it's not unsafe to add these?
Right. So I'm not the expert on Chialisp, but I imagine that some of these, at least, you want to keep out of coins. Like Quex brought up, like in certain paths, you might want to issue these conditions so that you cut them off after a certain time. But another, like a safe place to put them would be to put them in the solution. Like the way we do delegated puzzles right now is that it's really the solution representing the transaction that we limit. So you can create a solution which becomes which has an expiration time on it. So after that expiration time, you can no longer use that solution to spend the coin. You will have to come up with a new solution. So that's really sort of closer to the offer use case.
Okay,
but once you bake it into the coin, then you risk, like if all of your paths to spend the coin end up with an expiration, you might brick the coin, right? So that's something you have to be careful about.
Yeah, so the developers will have to be warned not to use these in the coin itself, and only in solutions, so that if that time does pass, then they can still spend the coin later.
Yeah, it's definitely a great power, great responsibility kind of thing.
Okay, we're giving you the power. Be careful with it. I just realized we haven't talked about these other two yet. We skipped over these. I guess for Arvid more, do you want to just explain what these are? The my birth height and my birth seconds? Right,
so these are also basically trivial conditions to add, and Bram thought they were a good idea. I'm not entirely clear on what the use cases are, but basically you just ensure or assert that the coin that's being spent was created at a specific height or a specific time, and if it wasn't, then that fails the condition.
Yeah, the use cases aren't entirely clear. I'm sure we'll come up with some feature, but the main reason that we're adding these is because we will, with the addition of the assert before conditions, it is possible to actually do these conditions in a really complicated way. And so should those use cases arise, we want it to be easy via a trivial condition, rather than having to do, you can use 4 of the other 8 conditions to assert your birthday, basically. And it's a whole mess trying to like having to malleate that every time the block passes and stuff like that. So this is really just taking that thing that now becomes possible with the assert before conditions and just making it a bespoke condition so that we don't have to deal with that headache in the future.
Great. I just realized I don't think I ever asked, do these have a CLVM cost associated with them?
No, none of these
So
conditions
just
have cost.
so only creating coins and signatures has CLVM cost, right?
That's right.
So okay. So it's more just a pain that you would have to use for conditions to assert your birth height.
You would pay the cost for the CLVM code itself, right? The size of
Oh,
it.
right. The bytes have a cost. Yeah. Okay. That makes sense. So this just makes life a little bit easier for certain use cases potentially.
Yeah, and if you're doing it with the 4 other conditions, it requires input of like what the current date is basically. So every time that changes, you have to change some solution value in order to make the spend pass. Whereas assert my birth height, you just put it in there as some number, and then you never have to malleate it.
Oh, I see. Okay. And so these were mostly just added because we're adding these other conditions anyway. So why not add these nice to have things? So then that brings us to the soft fork. And so I guess adding any new conditions requires a soft fork of the blockchain. Arvid, do you want to explain, I guess, why it's a soft fork and then how that's going to work?
Right. So, well, it's a soft fork because these conditions previously or currently, I suppose, are unknown and are just accepted by the consensus rules. They're not accepted by the mempool rules, so you can only really get them into a block if you win a block and you stick them in there, not going through the mempool. But the rules are strictly more strict, so to speak, because these conditions have the ability to fail a block, whereas today they don't. So that's why it's a soft fork.
All right. So if I just use 65 and then just put something in right now, it would just be no op, just automatically pass.
That's right.
And then it could fail in the future because it's looking for a puzzle hash.
Right.
Okay. And so there's going to be, this will get into a future build, I guess. And then we'll have a fork height that, does everybody need to upgrade by the fork height? Or is it just a risk if you don't upgrade that potentially coins? What is the risk if you don't upgrade by then?
The risk is if you're a farmer, if you're a farmer and someone no, actually, I don't think there's. So the main risk is so a farmer that has not upgraded will not accept any transaction with into their mempool with these new conditions in them because they will fail the old farmer's mempool. So you will still be able to win blocks and make blocks. You just won't include any transactions with these new conditions in it. So you might lose out on some fees. I believe that's the risk.
But would it kick out any of these spends if they're in the mempool, or would just the next farmer pick them up?
It would never accept them into its mempool.
Oh, right. I see.
And since it's a soft fork, all the blocks that other upgraded farmers produce will still be considered valid from the old farmer's point of view. It will still farm on top of them.
Okay. So as far as the soft fork risks, that's pretty minimal then in this case, from what I'm hearing. I mean,
that's my understanding.
Risk of losing a small blockchain fee if you're a farmer. Not a huge risk to the network. The next question I wanted to ask about is the mempool itself, and is there some new logic required in the mempool in order to accept these conditions?
Yes, the mempool needs to become a little bit more sophisticated. It will need to evict transactions that as they expire, basically.
Oh,
That's
okay.
pretty much it.
Oh, right. I see. So, and because we're only using these conditions in the coin spend itself and the solution, then they'll just get kicked out, and then someone can try to spend them again.
Right. I mean, once you submit something into the mempool, you have both the puzzle reveal and the coin solution together, right? So you have everything. It doesn't really matter whether the condition comes from the coin or from the solution. Once you have the spend bundle, it's a package and it's valid and it will produce potentially one of these conditions. So we just mark it as this is its expiration time. And whenever we get to that block height or that timestamp, we evict them from the mempool.
Okay, and so does this add any extra workload then to the full nodes as far as mempool logic?
It adds a little bit more bookkeeping, basically. So we're transitioning the mempool to actually use a SQLite in-memory database to track these properties of transactions. And I'm sort of hoping that we can also simplify some other parts, like for the existing assert height, we actually have a separate table or like a separate dictionary for those. And I think it could simplify the mempool a lot to fold those into the SQLite database eventually as well. But that's a long-term thing.
Yeah, okay, so not part of the chip though.
Right, no.
Okay, so that's all the questions I had, but did you guys have any other security things that you wanted to bring up or anything else with this that you wanted to bring up?
Yeah, I just reiterate there's also there's being careful with the condition yourself in the Chialisp you write, but there's also if you have for some reason some puzzle that allows some other actor to output their own conditions in a way that you can not change after the fact, they can potentially brick your coin, right? So this is not just be careful of what you yourself are doing, but what you're allowing other people who are spending your coin to do.
Okay, so
when
we're
you're
gonna
writing
have to,
Chialisp.
we'll have to document pretty thorough warnings to make sure that doesn't happen.
Yeah, it's a very weird scenario. I don't know why you would write something like that, but if I come up with an example, I'll try to write that up or give that to you to write up so that we can make sure people are aware of it. But yeah, just if people are outputting conditions is now a little bit more dangerous, because before they could only make your spend valid, right? But now they can make it invalid. So
Right. Okay, something to watch out for.
One other thing that I think is worth mentioning is so this is primarily a mempool feature, I would say. The validating it in the consensus rules is very simple, but it's the mempool that's gaining most of the logic. And one detail in our implementation that we're working on right now is if you have, let's see if I get this right. If you have a transaction that hasn't expired in a mempool, and then it expires, we evict it, and then you have a reorg where it would have become valid again. You have a reorg that goes back to a lower block height, like but a heavier chain, presumably. We won't reintroduce it to the mempool. So there's a small risk that it will be evicted and then not included in a block, even though it could have been. It's really tiny risk and or quirk.
I see. Do you have an instinct for how often reorgs happen in Chia?
I don't, and I think my impression is that it's quite rare, and I would expect that it would be even rarer to have a reorg where you end up at the lower block height than you started.
Right. Yeah. So this sounds like nothing too extreme. And then if that did happen, you could have gotten your spend in, but not the end of the world. You just can spend it again.
Right. Presumably, if you have these conditions, you sort of expect to resubmit them periodically anyway.
Right. Oh, yeah. That makes sense. Okay. You guys in the audience, did you have any questions for any of us before we wrap up? Sounds like no.
Yeah.
Karthik?
Yes.
Oh, okay.
Sorry.
Yeah. Go ahead.
Yeah. So I just have a question about how, if you already have a plan of how this will be implemented in the offer file. Like this will be, I can imagine that this will be the condition that will pass into the coin spend of the offer coin, right? Is that something that?
Yeah, there's no sketched out implementation yet, but it's really should be no harder than just adding another parameter to the RPC and all the way down the stack, right? Right now, you specify parameters of like how much you want to offer and whatnot, and it's just another parameter like that. It's just another condition to create, so it shouldn't be very difficult. It might be a little bit there might be a little bit of work in tracking stuff that expires and marking that automatically, but in terms of like creating the offers, it should be pretty easy.
Cool. Thank you.
Thanks, Matt.
Yeah. And another question is about the testing. So for the soft fork, we probably, so if you want to test this this new stuff, you have to probably create your own testnet with more than 51% of the new nodes. I mean, new version of the client, right? So that's, I try to think about it, how to test this before before it hits the mainnet.
That's a good question. I'm not super familiar with our testing tools for Chialisp developers. Our sort of the core of our simulator that we use for our own continuous integration test definitely allow you to change the soft fork block height. For instance, that's how we test our implementation. So we can run the tests with a normal block height and then where we set the block height to 0, so that as if the soft fork had taken effect or activated already. So we can run all of our tests in both cases. So there might be some tweaking to the tools to be able to test this.
Oh, cool. Thank you. Yeah, I think simulator should probably help with this too.
Yeah, I don't really have any additional insight other than use a simulator too. So we will have to come up with a robust test system for this. So any other questions before we wrap up? Okay, well, thanks for joining us, and thanks Arvid and Matt for coming on and explaining this chip. And we are looking for reviews for this chip, so please go to GitHub and leave your review there, or we can always chat about it on Keybase. All three of us are on most of the time, so feel free to hit us up with the questions. And this chip is being fast-tracked, so we're going to try to get it out there rather soon. I can't promise any dates, but this is something that we're trying to do fairly quickly. So please leave your reviews and let us know. Thanks for joining, everybody.
All right, thanks.